right, class, today we are going to start a brand new unit called proportions. Before we learn about proportions today, we're going to learn about ratios. Remember, a ratio is just where we compare, it's a comparison of any two numbers. Okay, so this fraction up here on the warm-up is actually a ratio. And what I want you to do real quick is go ahead and do the warm-up. All right, you're going to go ahead and simplify these two fractions, okay? Or these two ratios. Go ahead and hit pause, and then when you're ready to check your answers, hit play again. All right, on problem 1, you're thinking what goes into both 14 and 32, all right? Both of them can be divided by 2, all right? Remember, anything that is an even number, meaning it ends in 0, 2, 4, 6, or 8, if it's an even number, 2 goes into it evenly. 14 ends in 4, 32 ends in a 2. So both of them are divisible by 2. So 2 goes into 14 7 times, 2 goes into 32 16 times. And then you're thinking, can we simplify it again? Is there anything that goes into both 7 and 16 evenly? If you're thinking 2, well guys, 7 is not even. 2 goes into 7, 3.5. We can't have decimals. No decimals, so you're done. On number 2, all right? You should have seen, so let's see, 3 goes into both of them, or you could do 2. All right? If we did 2, since they're both divisible by 2, they're both even, we would have gotten 6 over 9. All right, but 6 over 9, there's something that goes into both of them. Okay, 3 goes into both of those, which means you're not done. 3 goes into 6 2 times. 3 goes into 9 3 times. Then we would be done. Okay? You could have also started off with doing 3 into both. 3 goes into 12 4 times. 3 goes into 18 6 times. All right? So we could have also gone this route. You could have done the 3 first, but then I see I'm not done. 2 goes into both 4 and 6. 2 goes into 4 2 times, 2 goes into 6 3 times, then I'm done. All right? Now, there was another one, not sure if any of you saw it, but actually, you could have also done 6. 6 goes into 12, 6 goes into 18, both evenly. 6 goes into 12 2 times, 6 goes into 18 3 times. You would have been done right away. So the bigger the number you pick, the less times you'll have to simplify. If you pick a small number, that's okay. All right, you just might have to simplify more than once. All right, but all of those work, and all of those will give us the answer 2/3. And then real quick, guys, if we end in 0 or 5, that means 5 goes into it evenly. Some of the tricky ones that you'll have to check is like, does 3 go into something evenly? Does 7? All right? Always, always check with your calculators if you're not sure what it is. All right, next. So, like I said, a ratio is a comparison of any two numbers. We can show this 3 different ways. So let's say that we're comparing A with B. All right? We can do it as a fraction. Oops. Or actually, we can do it like that. So a little colon. That means A to B with a little colon. Let's say we're comparing how many apples to bananas we have. We could also do it like this. You can write out the word to. So A to B. And then last, we can write it as a fraction. A to B, or A over B. Okay, and then eventually you'll have numbers instead of letters. So let's look at some examples. All right, this first example, it says, what is the ratio of triangles to squares. So we want triangles over squares. Well, first let's go ahead and use this picture and count up. We know we're going to need all of these, so we may as well count all of them up. All right, smiley faces. How many smiley faces do we have? 1, 2, 3, 4, 5, 6, 7. All right, go ahead and count up all the triangles. Don't miss this guy right there. 1, 2, 3, 4, 5, 6, 7, 8. So 8 triangles, and then go ahead and let's count up the squares. 6. Okay, and then if we want the total shapes, add all of those up with your calculator. You can add them up in your head. You should get 21. All right, so coming back over here to problem 1. They want the ratio of triangles to squares. Guys, this is super important that you go in that order. We have to have triangles first. All right, we have 8 triangles to 6 squares. All right, if you write this, that's going to be wrong. That's squares to triangles. So it's very important that we are reading carefully with this. It's ratio of triangles to squares, and then we need to simplify. All right, we can simplify. 2 goes into both of those. All right, it's going to simplify to 4 over 3. All right, next, what is the ratio of smileys to squares? So again, we have to write smileys first. How many smileys were there? There were 7 smileys to how many squares? To 6. So our ratio would be 7 to 6 or 7 over 6. Again, we have 3 different ways that we can write ratios. And last, we want the ratio of squares to all shapes. So we would do squares over total. Okay, we have 6 squares out of 21 total shapes. So it would be 6 over 21. Okay? Go ahead and look at these next 2. They tell us that we have a science class. In the science class, the ratio of boys to girls is 2 to 3. So again, it goes in that order. They say boys first, which means there are 2 boys. Then they say girls second. So boys to girls, 2 to 3. There are 2 boys for every 3 girls. Okay, that's our ratio. So for this first one, they ask for the ratio of girls to boys. So girls over boys is what they want. And guys, writing your words, all right, what you're comparing will really, really help us out for when we do our word problems. So this G over B is really good. We want to get in the habit of doing that. All right, girls. We have 3 girls. For boys in the bottom, we have 2 boys. So that would be our ratio. All right, number 5. They want the ratio of boys to total. Now, they don't give us the total. We have to figure it out. So guys, let's say we've got, they told us that our ratio is 2 boys and girls. Let's see if it'll let me use purple. 3 girls. Should have used blue for the boys. There we go. All right, so we've got 2 boys and 3 girls. So that means we know that we have 2 boys for this ratio. It's 2 boys out of how many total people? We're only using the information that they've given us so far. It's 2 boys, 3 girls. That means there are 2 boys out of 1, 2, 3, 4, 5 people. So our total, just using that ratio, is 5. Just like there are 3 girls out of 5. Right there. We're only looking right there. We're not actually looking at the class. We're looking at the small ratio. This is our simplified version. There might actually be 30 total students, but right now we're looking at the simplified version. So that's why it's small numbers, okay? But again, it's 2 boys out of, we add that, it's 2 boys out of 5 total students. Okay? Let's go ahead and look at 6 and 7. They tell us a football team won 8 games out of 14. So, they won 8 games. So 8 is how many games they won. What does that 14 represent? Yeah, the 14 represents our total games. Okay? So this first question, number 6, wants how many games, the ratio of games won to games lost. Well, we know that they won 8. So they told us that, and then they told us the total number of games. They didn't tell us how many they lost, but we can figure it out. Well, we know that they won 8 out of 14. So how many did they lose? They won 8. That means they lost the others out of the 14. So 14 minus 8 will give us 6. So they lost 6. So again, this is not simplified though. We need to simplify that. All right, the simplified version is going to be they won 4 games, they lost 3. Okay? We use the simplified version. All right, next we want the ratio of loss to total. So lost to total. And if you want to do L over T, that's fine also. So they lost 6 out of 14 total games. Are we going to leave it like that? No, we got to simplify that. So you're thinking what goes into both. 2 will go into both. We get 3 over 7. And we can't simplify anymore. All right, now guys, this simplified version here is like what we have up here. All right. Looking at this simplified version, they didn't actually only play 7 games, they played 14. But 7, that's the simplified fraction. Just like this is our simplified fraction up here with 4 and 5. All right? That's not how many actual students we have in there, that's just our simplified version. All right. Last thing we're going to talk about in this set of notes is a unit rate. A unit rate is a special ratio that will always have a denominator of 1. Okay, a denominator of 1. So, some common examples of where you will see this in everyday life. When you go shopping or when your parents go shopping. Food is always sold per pound. Okay, apples, produce, meats, fish. Chicken, all right, steak, hamburger meat, it's all sold per ounce or per pound. So these apples are $1.99 per pound. What that means, if we write it as a fraction, it's $1.99 per pound means per 1 pound. Okay? Now they actually abbreviate pound like this. Pounds. Or we could write it out like this. Okay? So, per pound means per 1. All right, 20 miles per hour. That's 20 miles per hour. It's technically per 1 hour, but if we just say per hour, we know that it's per 1 hour. Again, we have a denominator of 1. And guys, when your parents are driving, if you're driving anywhere, we always have the speed limit. So 60 miles per hour. The miles per hour is abbreviated MPH. So miles per hour. All right, that's how many miles you should be doing per 1 hour. And then last, 5 snaps per minute. All right, so that would be 5, and then snaps, and then per 1 minute. So we can put minute or 1 minute, either one. Again, per means 1. Unit rate is when we have a 1 in the denominator. Okay? One last thing I want to talk about. These are equivalent, okay? Even though this is a simplified version, they equal each other because they're the same thing. It's just one is simplified and one is not simplified. But when we ask for an answer, we always want the simplified version. All right? Just like these are the same. They are equivalent, but this guy is a simplified version. All right, let's go ahead and try the back. When you are done, go ahead and get checked to move on to the next thing. Good luck.